The second stage will ignite, followed by payload fairing jettison from the DART spacecraft about 3 minutes after liftoff. The second stage will cut off and then restart a few minutes later to put the satellite in the proper trajectory. About a minute later, the second stage will cut off and DART will separate from the second stage. The mission's goal is to slam DART into a harmless object measuring about 524 feet, 160 m, across, to see whether its orbit can be shifted. And according to John Wormersley at the University of Oxford, the proof-of-concept mission will, consequently, test NASA's ability to protect the Earth from a real-life doomsday scenario. In the 1998 blockbuster directed by Michael Bay, Armageddon, a colossal asteroid is found barreling towards the planet and a ragtag group of deep-core drillers are tasked with blowing the space rock up using nuclear bombs. NASA's DART may not be as flashy and its intended target does not pose any danger to Earth, but the technology and techniques being put to the test could very well save the planet from destruction in the unforeseeable future. Professor Wormersley said, "It's exciting because it's different. It's not a space science mission like the ones we are used to which help us understand the origin of an asteroid or what it's made of. It's a technology test, and a test of a potentially very important capability for the future of the planet, one we hope we never need to use, but which could save millions of lives." NASA's target is a binary asteroid system scientists have officially named 65,803 Didymos. More specifically, NASA's spacecraft will ram into the smaller moonlet known as Dimorphos or the more affectionate Didymoon. The space rock measures about 524 feet, 160 m, in size and according to NASA is representative of the asteroids that could pose the most likely significant threat to Earth. Dimorphos orbits a bigger space rock that measures about 1,560 feet, 780 m, across. DART will slam into the moonlet at speeds of about 6.6 kilometers per second or 14,763 miles per hour and theoretically alter its orbit by less than a fraction of 1%. But this will be enough for NASA's telescopes and sensors on Earth to detect a shift in the asteroid's orbital period. If the same technique, so-called kinetic impactor, is applied to an asteroid heading in Earth's direction, if struck early enough, even a small change in its orbital velocity could steer it clear of our planet. However, this will not happen until late September 2022 when DART rendezvous with Didymos about 6.8 million miles, 11 million kilometer, from Earth. And if all goes according to plan, Professor Wormersley argued it will bolster NASA's planetary defenses. He said, "The best result will be first, that DART successfully reaches and impacts Didymos, which is one of a pair of twin asteroids traveling together around the Sun, and then that this impact changes the way it orbits its twin just in the way that NASA scientists calculate and expect from computer simulations. If that happens, it will give us confidence a future mission to redirect an asteroid away from Earth could in principle be designed and constructed should it ever be needed."